Hi, Professor Wright. This is my video explaining my exam 2. So when I first saw the TikTok video, I saw that the leaves were not in motion because the gravitational force and normal force acting upon it were equal until an unbalanced force, which was the person that jumped onto the net, caused it to shift up and the leaves began to fall down because there's no regular normal force on it. So for the second law, the person that jumped onto the net hit the net with a force that was equal to its mass times acceleration it was having. And then for the third law, once the person hits the net, the leaves go up. This happened because when the net was being flat, there was nothing acting upon it. But when the person hit the net went down with the momentum, with the acceleration it gained from the person hitting it, and then shot back up. Because for every action that occurred, for the reaction that occurred, there was an opposite and equal reaction with it, which was a net going up, which brought the leaves up, which resulted in the leaves coming down. So for problem 2, for FanClan, I first started off with writing out the forces on it. So I put Fn for top, Fgy for the bottom, Fx, and then the force applied to it. So my axes were up was y and left was positive for the x direction. And then n, the sum of all forces equals mass times sum of accelerations. And so our constant was that ay equals 0, and then if the static force applied is larger than if the static force is larger than the force applied, the block would not move. And then for L, Fgy equals mg cosine theta, and then I calculated Fs just to have it, which equals 51n, and anytime the force applied was larger than 51n, the block was in motion. And I put Fk equals 0.4 mg cosine 30, which was determined when we had Fn equals, when we did A, which was the sum of all forces in the y direction will equal 0, so the normal force minus the gravitational force in the y direction will equal 0, so Fn would equal mg cosine theta. So now we started calculating the acceleration of the blocks when the force was applied to it. So to do that, we did Fx equals max, and then the sum of all forces in the x direction was the force applied minus the kinetic friction, which equals max. So to calculate the acceleration of the block in the x direction, we just divide the force applied minus 0.4 mg cosine theta, all divided by m. So now is the end part of FanClan. So the first 4 seconds the block didn't move because the force applied to it was way smaller than the force that was the static force. The static force is 51, and then the force applied was less than that, so obviously means no motion. Then after the 4 to 8 seconds, a force applied that was applied was 75 newtons, which is larger than 50 newtons. So then we plugged it into our acceleration formula we found, and we found that ax1 would equal 4.10 meters per second squared. And then we found the acceleration when 100 newtons was applied to it at 1 second, which would be 6.6 meters per second squared. And then we did it for the last interval, which was from 9 to 10, and the force applied was 125 newtons, which is way larger than 50 newtons. So we plug that in, and then we get acceleration of 9.10 meters per second squared. So to find how far the block moved until 10 seconds, we had to find the distance that it traveled when the force applied was larger than the static force. So to do that, I did delta x would equal fv squared minus v initial squared over 2a. So to calculate the velocity, we would use the formula v would equals vi plus at. So our initial velocity was 0, and then to calculate the final velocity, in this case for delta x1, we did 4.1 times 4, which would equal 16.4. So we put that squared divided by the accelerator to a, we got 32.8 meters. And then we repeated that with the different acceleration to get the following velocity, and we got the delta x2 equal 19.7 m, and then for the final change in position, we got 27.5 meters. So when we combine this, we got a total of 80.05 meters, which is way longer or larger than the length of the inclined plane, so that means the block is off the incline. Okay, so for problem 3, my F, which was right over here, we had that on M3 we had forces applied on it was FMG, which was down, F3, 3 on 1, which is up, and then F to the right, which would be the kinetic force. And then on M1, the forces applied would be tension to the right, the normal force, FG, or MG, the force of 3 on 1, the kinetic force, and then I said the kinetic friction, the kinetic friction, not the kinetic force, but then, so that's the kinetic friction, and then to the left, the F31 is supposed to be the kinetic friction on 3 on 1 from the top, because as it's moving, it's getting dragged along. So the axis of my things were Y and X. N for fan clan was the sum of all forces equals M times A. And then for C, for fan clan, I did A, Y, M3 equals 0, A, Y, M1 equals 0, the acceleration of M1 equals negative acceleration of M2, tension 1 equals tension 2, and then F 3 on 1 equals mg3, the mass of 3 times gravity. So our L in fan clan was, we got Fm1 would equal tension minus the friction, the kinetic friction force, minus the kinetic friction force of F3 on 1, which will equal Ma. For the forces applied on M2, we have M2G minus T, which is the mass of 2 times gravity minus tension. And then the forces on Mg were F31. So now comes the A part. So I manipulated the original F1 formula. So I got tension to equal the force of kinetics plus F31, the force of kinetics, and then plus M1A. And then I kept the formula the same for M2G minus tension equals M2A. And then I plugged in we solved for tension into M2G minus T equals M2A. So I got this formula, and then using that formula, I put in numbers in for the N part of fan clan, the last N, and got my acceleration to equal 6.21 meters per second squared for AM1, and then AM2 would be negative 6.21 meters per second squared. And to find the acceleration of M3, I just did the kinetic force of F3 on 1, which would equal 0.1962. I calculated here on the side. 0.1962 is the force of it, so times that by 0.1, it's just the kinetic coefficient, divided by 0.2, the mass of it. Our acceleration for M3 was 0.0981 meters per second squared. And for the last, and my favorite problem, was the calculus question for number 4. So for F, these are the forces applied to it. Fn, which is up, Fgy, or Fy, I don't know why I put Fy. I'll just put mg to make it easier, and then the kinetic force to the left. And then I made the I put it to the right and made it seem better for me. So the axis where y was up, x and x-axis, and then force equals ma. So the sum of all forces equals ma. C, I did ay equals 0. I'm not sure why the 0 didn't show up. And then for L, I said Fn equals question mark, and that's the same for all the questions beforehand. And then for A, we started manipulating stuff, so Fi would equal 0. I don't get why I put Fn minus Fy. That's weird, that doesn't move, so I'll just put mg again. And then Fn would equal mg in the y direction. And then the sum of all forces in f of x would equal ma. When you did F minus Fk, you would get F minus Fk would equals ma, and when you plugged it in, you got F minus the coefficient of kinetics times mg, because mg is the normal force in this case, equals ma. So when you divide that by m, a will equal force minus uk and g over all of it over m. So what I did was I started integrating this so I can get the velocity. So the way I did this was I factor out the 1m from everything, so I can apply that afterwards. And then I integrated these two separately, but with the same intervals of 0 to t. So it was the right side, the UKMG, is actually easier because they're all a constant. So if you remove that, our thing that's being integrated is just 1 So that just becomes t. So when you integrate it, you just get negative UK mgt. And then to integrate what you gave my group, the at to the 4 plus b t squared over t squared or alpha and beta, what I did first was I plugged it in the calculator to make sure that if I divided that by t squared, that the numbers are equal to each other. So if I say, for example, I put 2 for t, and then a was 5, b was 3, that the answer of this on top will equal this, once you factor out, or once you divide out the t squared, which it did, so it made the integration much simpler. So what I did after was I did at squared plus b delta t, integrated that, and I got a t3 divided by 3 plus beta t minus uk mgt, and then to get the final velocity formula for vt, you just divide everything by m. So the first part of the velocity formula would be at to the power 3 divided by 3m plus b or beta t divided by mass minus ukgt. Since mass was on part of that formula, you just get that. And that is my test. Also, here's a tree. Shadman was upset that he drew a tree on one of my practice exams and you didn't say anything about it. So I hope you enjoy the tree, and I hope you enjoy my exam and explanation. Have a good day.